Lesson 5, Logical Operators. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. We have already introduced the bool type variable, which can take on the logical values true and false. In this lesson, we show how to combine Boolean variables into more complex logical expressions. The basis for creating logical expressions are the three logical operators AND, OR, and NOT. In C++, these operators are designated with a double ampersand, double vertical lines, and an exclamation point respectively. In logic, it is common to use the letters P and Q to represent Boolean variables in logical expressions, and we will follow this convention here. Since NOT is the simplest of the operators, we will begin by demonstrating its usage. In our first program, we begin by declaring a Boolean variable p and assigning it the value of true. Then we output the values of p and not p. Next, we set p to false and output the values of p and not p again. Executing the program, we see the output, which describes the truth table for the not operator. Since 0 represents a Boolean value of false and 1 represents true, our truth table looks like this, with the not operator simply changing true to false and false to true. Next, we will look at the OR operator. This operator acts on two Boolean values and is true if either of the values is true. To illustrate, consider this program. We begin by declaring two Boolean variables p and q and assigning them both the value true. Then we output the values of p, q, and p or q. After this, we assign q the value of false and output the values again. Then we assign p the value of false and q the value of true and output them again. Finally, we set q to false and output the values one last time. Altogether, this generates all four possible combinations of values for p and q. Executing the program, we see the output, which represents the OR truth table. The OR truth table looks like this. The third column represents the values for the OR operator when the arguments p and q take on various values. In our final program, we demonstrate the AND operator. This operator is true only if both of the operands that it acts on are true. As we did for OR, we will generate a truth table for the AND operator. Using the previous program, we changed the words OR to AND and changed the operators to double ampersands. Executing the program, we see the output, which represents the truth table for AND. The truth table for AND looks like this. Again, the third column displays the values for the AND operator for the various values of p and q. Lastly, we note that the NOT operator acts on only one value, while the OR and AND operators act on two Boolean values. Operators that act on one operand are called unary operators, and operators that act on two operands are called binary operators. These operators can be further combined into complex Boolean operators like this, which we can use to control the flow of our programs. This concludes the lesson.